Supercritical fluid extraction. It includes introduction, property, its extraction components, method, objective for commercialization, advantage, disadvantage, and precautions. First of all, what is supercritical fluid technology? When your fluid is having the temperature and pressure more than critical point, then it reaches to the state of supercritical, and when you use the supercritical fluid for extraction, then it is called as supercritical extraction. Afterwards, properties of supercritical fluid. Physical and thermal property of supercritical fluids is basically between the liquid and gas, so it is called as dense gases. When you have the supercritical fluid, then it has property of liquid, density like liquid, and diffusive. It is more higher diffusive than liquid, so it is a property of gas. So it has both the property of liquid and gas. It is excellent solution power, and it has less reduction in the surface tension with low viscosity. Therefore, why we are going to use supercritical fluid for extraction? Because it has high penetration power in any type of the material, so it has good extraction capacity. Now, the solvent property of the supercritical fluid is basically used for different categories in different applications. When you compare solvent extraction with the supercritical fluid extraction, now in this solvent extraction, when your solvent passes through the solids, it dissolves solute, extract, and then we are going to remove this raffinate or solvent. Now in the supercritical fluids extraction, when you pass, then it dissolves solids, extract is separate out, and supercritical solvent is available in your substance. So hence it resembles solvent extraction process, but the solvent used is supercritical fluid. Now, the procedure of supercritical fluid, it is the process for separation of one component from the another using supercritical fluid as the extracting solvent. Now see the component of each and every part. It has the CO2 is used as a supercritical fluid. It passes through the pump, and then it reaches to the extraction cell, where after passing the extraction cell, liquid solvent is separated and solid phase is trapped out in your system. And now the first step for the extraction is introduction of feed into the first you introduce your fed into extractor, and then formation of mobile phase, matlab it's your supercritical fluid, mixing of solute with supercritical fluid, and exposure of this mobile phase to the pressure of 50 to 508 atmospheric and temperature 300 degree near to above critical point for enhancing mobile phase solventing power, and then isolation of these solutes by precipitation. CO2 is a vapor form, is compressed into liquid before becoming supercritical, and then extraction takes place. Now first component is the fluid reservoir. The CO2 is used as a fluid. Then second component is pump. It is used for reciprocating pump is used, and here it is used for transportation of the fluid. We are going to use pump. Then this fluid is pumped into the extraction cell. Usually we are going to use stainless steel cell, which has high pressure 300 to 600 for solids, and open tubular capillary column is used, so it can allow the easy transportation of the solvent. Now next component is extractor. It maintains the pressure change inside the cell, and this restrictor is of two types, fixed one and the variable one. And after this, your solvent system is collected into trapping system, and then it is sent to the detector for send it, which is detected, attached with the uh, flame ionization detector of gas chromatography. Now, after extraction, the role of trapping system is the supercritical fluid with recycling or trapping system. Recycling of system can be done by reduction of the pressure. Here, supercritical fluid unable to dissolve the solute, separation of soul under gravity and the gas at low pressure is compressed back into supercritical condition. So, and second recycling or trapping system is reduction of pressure. Solid drops and recovery of solvent without recompression. So by this way, you can separate out your extract with your supercritical fluid. And third is pumping supercritical fluid to expansion tank, where it becomes gas, resulting in very less solubility and the separation of the solute. So these are three ways by which you can separate out your extracts: reduction of the pressure, reduction of temperature, or pumping the supercritical fluid to expansion tank. When you are going to go the pumping of supercritical fluid expansion pipe, this extraction vessel, pressure valves, and here this extraction, CO2 extract separator, extract out, and CO2 is separated from top and it is condensed. It is again recycled. Now, why we are going to use the CO2 in the supercritical fluid? Because it has some critical property. And the very important 2 points here is critical temperature and critical pressure. It is very important, and there are many lot of solvent you should remember, like carbon dioxide, ethane, nitrous oxide, chlorodifluoromethane, ammonia, methanol, all can be used, but mainly we can use carbon dioxide because it has less temperature and pressure. Both are the less, so it can be easy to achieve. 31 is the temperature, critical temperature, and critical pressure is 34. So it can be easily achieved while doing extraction. That's why. Now, see, when in the carbon dioxide, you can see separate phase of carbon dioxide with the, but when you increase the temperature, then when once its critical temperature pressure has been achieved, two phases of liquid gas are mixed and there is no meniscus is out here. Meniscus slowly dissolves, and when it becomes homogeneous, then it reaches this supercritical condition. Now objectives for commercialization: separation of multiple solutes. As solubility of solute in supercritical fluid may be a function of temperature and pressure. The use of modifiers and enhance versatility or efficiency. And the multiple solutes in supercritical fluid. Separation of solute is by using two stages. One is first extraction and second is second extraction. The first extraction is similar, but in the second extraction, the solution of the remaining solute in the solvent result the isolation. Basically, it is, see here we have given the examples. Dried gingers is solid and it is extracted with CO2. But the condition for first extraction and second extraction is different. Similarly, for coriander it is also given. So commercially it is used for this type of extractions. Advantage: elimination of organic solvents, which can reduce the risk of storage, rapid process because of the fast diffusion and solution capacity, suitable for extraction and purification of compound having low voltage present in solid liquids, susceptible to thermal degradation, and complete separation, continuous process, low handling cost, solvent recovery is very easy, versatile and effective. Limitations: prolonged time, penetration of ion is rapid, but solute diffusion from this is difficult. Modeling is inaccurate, scale is not possible due to this absence of fundamentals, expense a little bit, and reproducibility is not achieved. Adequate contact time should be given, otherwise these are the precautions that we have to take care. Equilibrium should be achieved when doing extraction, and it is used for food science, mainly in fat, meat, egg, milk, chocolates, and all natural products. The extraction of herbals, byproducts, fruits and vegetable waste, and these are the applications. Thank you.